Today, the topic we are taking is optics, light waves. Now, as we can see, light is a luminous, energized electromagnetic wave. What we mean by electromagnetic wave is that a wave that requires no material medium for transmission. For instance, sound wave require air as the material medium for its transmission. For instance, if we are on the surface of the earth and I'm communicating with another person, the person will hear me. But when we are in the outer space where there is no air, which is material medium, the person will not be able to hear what I'm saying. The reason being that sound wave require material medium. Therefore, sound wave is not an electromagnetic wave. So any wave that does not require material medium is known as electromagnetic wave. This where the light is categorized. Now, we say electromagnetic wave because it requires no what? Material medium for transmission. Now, light is a luminous energized electromagnetic wave which causes vision sensation on our retina, thereby causing us to see. So the light wave enables us to see. Now, we have two major sources of light wave. The first one is natural sources, and the second one is artificial sources. Example of natural sources of light is the sun and the stars, as well as the light flies that we normally observe, especially during rainy season. Then example of artificial sources of light is a candle, electric torch, electric lamp, incandescent fluorescent lights, and arc light. Luminous sources of light generate and emit light by themselves. Example of luminous sources of light include the sun, the star, the fireflies, and the artificial sources of light. Non-luminous bodies are seen due to reflection of light falling on them. Like for instance, if you look at an opaque object such as a brick, we can be able to see a brick during the daytime because of the reflection of light ray that is falling on it. That's why in the night, when there is no light ray, we will not be able to see the brick because no light is falling on that brick and there is nothing like a reflection. Now, light transmission. If light shines on a body, part is reflected, part may be absorbed, and part may fully transmit through the body. For instance, look at this rectangular figure. If a light falls on this object, that light falling on this object is known as incident light ray. Part of this light that is falling on this object may be sent back, and that is reflected back, and part may be taken in, that is absorbed by this object, and part may come out of this object, that is, there will be full transmission of light through the object. So anytime light falls on an object, part of it may be reflected, part of it may be taken in, that is absorbed, and part of it may pass straight through that object. Now we have three categories of bodies that may receive light. The first one are called transparent bodies. Transparent body allow light to fully transmit through them. That means when light falls on a transparent body, the light will pass fully through that body. Example of transparent body: glass, water, and so on. We can see objects with transparent bodies easily. So, like for instance, if a body is transparent, you can see objects on the other side of that body easily. Now, another category of bodies that light can fall in on is called translucent. They are called translucent bodies. Example of translucent body include tissue paper, frosted glass, which allow very small light to pass through them. So object cannot be seen through them easily. So why you can easily see through transparent body? Transparent body will not allow you to see object on the other side easily. Then another category of bodies that light can fall on are called opaque bodies. No light passes through the opaque bodies. Therefore, we cannot be able to see light through them. Example of opaque body include wood, bricks, metal, and so on. Now, there are other two parameters we need to take note of. The first one is the light ray, and the other one is the beam of light. There is a difference between ray of light and the beam of light. A ray of light is simply the path along which light energy flows. You can see this particular line represents a ray of light, a single line. When we have more than one of this single line, we have what is called a beam of light. So a beam of light is a collection of rays of light. And there are three ways that ray of light can be transmitted. We can have them in form of a parallel beam of light. We can have them as if they are moving towards a point. I'm talking about different rays of light converging at a point, coming together at a point. And we can also have different rays of light coming from a point. I mean spreading out, that is divergent. Now, a device in the laboratory that we use to transmit, to produce a ray of light is called the ray box. And the ray box may include just a source of light, the enclosure of the box, and then a slit or hole through which the light can emerge. Now, there's another concept that we need to talk about, and that is known as the rectilinear propagation of light. There is a phenomenon called rectilinear propagation of light. That means the phenomenon of light traveling along a straight line. There are many categories of experiments that will demonstrate the fact that light travels on a straight line. Like for instance, we can have a hollow rod. A hollow rod is a rod that has space through it, through which light can pass through. Like this plastic rod now, we can see through it. It's a straight rod. If we have a candle on one side of the rod, and then we look through the other side of the rod, we will be able to see the light ray traveling on a straight line, and the eye can be able to see the light ray. But if this rod happen to be bent, and like in this case now, if the light ray come from the candle, it will not be able to reach the eye because light travel on a straight line. So there is no way the light can bend and reach the eye. So that's one experiment. We can also have series of punctured cardboard. Let me say we have this cardboard puncture at similar points on a different cardboard. If these cardboards are arranged parallel, as you can see, the ray of light will pass through the slits or the hole of the cardboard, and we can be able to see on the other side of the cardboard. But if one of the cardboards is shifted in such a way that the holes are not in line, we discover that the ray of light will not be able to reach the eye because the cardboard will block this. So the light ray will not bend through the hole. Now, shadow. A shadow is an area in which light rays can never reach due to obstruction by opaque objects. What this one is saying that when you have an opaque object as we defined before, is an object that will not allow ray of light to pass through it. So any portion of the body of an opaque object through which ray of light does not pass through constitutes what is called a shadow. A shadow can be cast on a screen. Like for instance, let me say we have a point source of light. A point of light is a very small hole created through which the ray of light can pass through. If it puts an opaque object in the way of the rays of light, we discover that at the back of this opaque object, there is no light over there. This particular area will be completely dark, and that completely dark shadow is known as umbra. Now, if we have a large source of light, let me say the hole here, we make it to be larger, and we still put the opaque object in front. We discover that there are two categories of shadow that this will fall. We have certain area that will be completely dark, and certain area that will be gray in color, partially dark. So this completely dark section of the shadow is known as the umbra, and the partly dark or gray shadow is known as the umbra. Thank you so much. You can always reach me on the YouTube on Orekoyemi Segun Physics Mathematics Fundamental. Have a nice day. Thank you.